So here's what we're looking for, okay? We have to, you know how last class, whenever we were solving logarithmic equations, we had to have the same log base, right? And as long as we had the same log base, we really didn't even need it anymore. That's what we're trying to achieve here, except now we're dealing with exponentials. We have to have the same exponential base. So what you're looking at is okay, normally they give you a hint. Like they gave us a number 3 here. Well, the hint in this case is there's another way of writing 81 by using base 3. 3 to the 4th power is 81. Now that we have the exact same bases, we don't really need them anymore. We just need the exponents. So x equals 4. You would then need to solve from there, but there's nothing to solve. Your answer is just 4 in this case. Yes.
No, that 3 to the 4th power. We're gonna have a list of like exponents.
You know what? It's safe for me to say yes.
Okay.
But I'll show you a technique afterwards that can help you with that if you don't know it. All right, so looking at B, I'm gonna see if that trick works again, okay? We have the lowest base here is 4. Is there another way we can write 16 using base 4? 4 squared, okay? This one is gonna be a little bit different, but not too much. So 4, 3x plus 1, and then set that equal to 4 squared, but this is where this one's a little different. We have to do 4 squared times x minus 1. Now that we have the exact same bases, you just set these portions equal to one another. 3x plus 1 is equal to, and if you wanted to, you could go ahead and distribute the 2. Are you okay with that initial setup? Cool with that? Good. Then let's not even solve because we should know how to solve those by now. All right, looking at example C, once again, the trick is, and this works most of the time, the lowest base we see is 5. Is there another way of writing 5 to the 1 over, or to make it to where it equates to 1 over 625? And there it is. That would be 5 to the 4th power. But is it going to be 5 to the 4th power? Or is it going to be 5 to the negative power? Negative, okay, good, because 5 to the 4th power, that's 625, but 5 to the negative 4th power is 1 over 625. Now that we have the exact same basis, just set the exponents equal to one another and solve. Which, once again, we're not going to do that. This is primarily what we were doing last class. I'm just showing you how to get to the point where you would begin solving. Yes.
So on the music one, you like had like 4 squared and like times like immediately have to distribute it. Why wouldn't you have to add? Because like normally when you are multiplying exponents, you have to add them.
And what you're thinking about is if we're going into expanded form. And that just requires a different, that's a different style of problem. For these types of problems, we're not going to use that.
Okay.
It wouldn't work. Okay, example E. Just try it. Go ahead and solve it. Thumbs up, thumbs down. Don't ever play heads up 7-0.
Yes.
Yeah. Then we don't even need, we can just move on. No, there's need any explanation. We've all clear. Okay. Sure. Yeah. If you know, you know. If you know. All right, here are our bases already the same. For example, F.
Yes.
Yeah, so you would just, they're already the same. So just set the exponents equal to one another. Now we're not going to solve this one, but if whenever possible, I prefer not to have x squared be negative. So in this case, I would add it to both sides of the equation. and then solve from there. You need to factor and solve and then et cetera, et cetera, et cetera. Moving on. But
Just like divide by -1.
you could divide everything by -1, sure. And then once you did that, so it would be positive over here, right? That'd be fine. Then you'd want to have to move these terms and move it over to the left side and right side. Either way, that's fine. I think that the manner that I went, it eliminated a step. But either way is gonna work. All right, this is where you're gonna need your calculator. Get your calculators out. I haven't done this in about a year, so I hope I remember.
Reminder that you guys.
It's okay if I use the app just for today.
Sure, that's fine.
Do you have an extra?
Yes. Okay. Now for these types of problems. That trick that I told you a little bit earlier, it wouldn't work. The lowest base that they provide us is base 2. Well, I don't know 2 to what power is going to give us 13. I don't even know if it exists. It probably does, but I don't know what it is. This reminds me of a movie line that I'll tell you a little bit later. Anyway, so what you're going to want to do is now we're going to want to incorporate logarithms. If we were to change this to logarithmic form, we would have log base 2 of 13 equals x. You're going to need to know how to convert from logarithmic to exponential and vice versa. Very crucial. Now, in order to solve this, is where the calculator comes in handy. We're going to use what is called the change of base formula, not to be confused with the amazing 90s band Ace of Base. Anyone? I'll play some for you later. You'll love it. Okay. We're going to use change of base formula. It's going to incorporate a fraction. So what I'm going to do is I'm going to go ahead and set up a fraction symbol. I'm going to write down what it's going to look like, and then I want to explain it. Okay, on top of this fraction, I have log of 13. On the bottom, I have log of 2. What is the base now? Not 2 anymore. 10, very good. Yes, it's now base 10. We've changed to base 10 method to solve this problem. Now, here's how hopefully you can remember how to convert from this format to the change of base. Do we all know that this is the base, that number 2, that that's the base of this logarithm? The base will always go in the basement of the fraction. The base goes in the
I see
basement.
what you did there. I see.
4 years of college. I didn't learn that in college. I came up with that in mind. All right. Now, here's how you're going to enter this in your calculator. You ready? Alpha, y equals, enter. I like using the fraction symbol. Alpha, y equals, enter. Right here where my thumb is the log button. Hit it. And that's really bad. It's not easy to see. I'm sorry, y'all. 13 over log 2. Enter. And let's round to the thousandth place, which would be 3.700. Try example H. This one? 5 times 3. 5 is 125. See where you're going.
Let's see. Let's see.
Did we get 1.683? Yay! That's how you solve what? There was a no. You need help with this in just a second. That's fine. If you're not getting it, that's fine. I actually need to know that stuff. Just tell me after notes and we'll go over it together. Example I. There's some things that we're gonna want to do here first. Notice that we have 5 minus 3 times e raised to the x power. So we need to sort of chip away. We need to get e isolated. So let's first start by subtracting 5 from both sides of this function. Subtract 5 from both sides. So if you subtracted 5 from both sides, that's where we would be. Now divide both sides by -3. Now you might be able to use some logic here to solve from here, but if you didn't know what e to the x power is equal to 1, we didn't know that, then we're going to want to change from exponential to logarithmic. Now we're dealing with base e here. Is that log? No, it's ln. So this would be ln. Oops, I forgot to switch those. Sorry, 1 is equal to x. My mistake. Now, this is the natural logarithm. You're not really going to see ln much, but I want to show you where that button is in your calculator. Right there. So just hit ln 1, enter. 0. Your answer is 0. And then if you go back here, that kind of makes sense. E to the 0 power is 1. Anything to the 0 power is. Okay. Huh?
X is 1.
In this case, yes, x would be 0.
Well, is that a 1?
This right here is a 1. Yes, right.
With the 1 over.
Here.
Could you, no, that.
I'm gonna answer your question. Everybody start working on J. Okay, what now? Start working on example J, please.
Start with 1, like 1.
Yeah, here, I just forgot to swap these two. Whenever we convert from exponential to logarithm, it should be ln of 1. Yeah, I just forgot.
Oh, okay. Anything to the power of 1.
Anything to the power of 0.
Didn't have to do that.
I'm like plugging this out.
Oh, okay, great. So,
There's the ln, but now 1.
okay, so you don't have any or anything, it's like,
Oh,
assume, okay.
yes. .524. Yes. Good. For example, 2a. Here, I think that they have just given you something that looks like this, but they didn't set it equal to anything, right? Try not to let that throw you off. We're doing the same thing. If you wanted to, you could set it equal to x. You don't have to. You could just go ahead and just do change of base formula. Log 16 over log 3. Or it's essentially the exact same thing. They just have left out the equals x portion. You plug that into your calculator, you'd get the answer. Okay, now, as I mentioned, that was a lot of stuff that we've been doing up to this point. So we're going to go ahead and skip on over to example 3a. This would signify something that you would need to do without a graphing calculator. This is where setting it equal to x might help. That other example that I did, maybe not so much, but this one it would. All right, so if we were going to convert to exponential, it would look like this. 2 x power is equal to 4. 2 to the x power is equal to 4. Remember, this base raised to that power equals that. And then this is what we learned at the very beginning of class. If you didn't know what 2 to the x power is equal to 4 is, you could say, okay, can we use base 2 squared or cubed or whatever to equal 4? And in this example, you could. Another way that we could write 4 is 2 squared. Now that our bases are exactly the same, set your exponents equal to one another and solve. Here your answer is simply 2. Example 3B, we've seen something like that, but let's take a look at 3C. This is the one we're going to end on here. Everything else that I know we're kind of glossing over quite a bit, but it's just the same thing over and over and over and over again. So just feel free to use that as extra practice if you would like. Talk to me after notes if you want to see some of that explained. Okay, looking at this one, this is where it's going to be helpful to remind yourself that there's another way of writing the 5th root of 7 here. I'm going to go ahead and set this function equal to x, and I'm going to convert to exponential. This raised to that power is equal to that. Now, I'm not going to write the 5th root of 7. I'm going to write 7 to the 1/5 power. That's how you rewrite a root in exponential format. Now that our bases are exactly the same, we simply need the exponents. X in this case is equal to 1/5. Okay, your Delta math assignment is ready to go. If you need any help on it, let me know. Submit your notes on Canvas. And should you need any of this explained further, come see me. Yes.
Then you just.
And then you yeah.
How would you do one after that? It's like log base 2. 1
And what example is this in? Example H. Okay. Is equal to x. All right. So I'm going to go ahead and change to exponential. This base raised to that power is equal to that right there. 1/2. It would be -1. See, a lot of times if you'll just go through the process, looking at it in one format, this is helping switch it to the other. By doing that, everybody has that. Oh, now I see. Good.
Thank you.
You want?
For like example.
You don't know.
We need to know. Like.
You don't have to worry.
No, don't worry about that. Everything that you're gonna need to know, everything on this page. You don't need that.
What day? This.
Third, no, Wednesday, I think.